When you think of STEM careers, certain skill sets come to mind. Mathematical prowess, tech savviness, scientific reasoning, among others. However, being a STEM leader requires more than just technical skills. It also requires a well-developed set of professional skills. Jane MacMaster is using her engineering skills every day, leading Engineering Australia, which is our peak body in charge of over 100,000 engineers nationally. In her role as Chief Engineer, Jane oversees industry standards at all levels of their career, brings an engineering perspective to public policy, and engages in the critical aspects of public debate. Jane joins us today to discuss how she uses her engineering skill sets to address the complex societal challenges and has navigated her career journey from engineer through to leader.
Hello, everyone, and I hope you're all enduring the implications of the pandemic as best you can from wherever you are. I'm happy to be speaking on the topic of leadership today. Instead of summarising the helpful hints I've surmised from various books over the years, I thought instead I might reflect on my own 28-year career in the hope of identifying an insightful observation or two based on my lived experience. Somewhat to my surprise, I did quite quickly discover that for me at least there was a pattern, a system if you like, that I believe nurtures leadership potential and capability in a person over time. I'll leave it to you to judge whether this observation is insightful or not. So what I did was to reflect on the conditions and turning points over the last 28 years that brought me to where I am today, just over 1 year into a role that I feel incredibly honoured to hold, Chief Engineer of Engineers Australia. So here's my story and the observation I made on what is leadership. But perhaps I should start with what I believe leadership actually is, because leadership's one of those words for which there's no single agreed definition. Everyone has their own interpretation. For me, leadership is all about inspiring, guiding, and empowering people to achieve things. In my view, to be a good leader, you obviously need some level of people skills, but in addition, I think you need to be able to contribute valuable insights and judgment so that you can, in fact, inspire, guide, and empower people. So, I graduated in 1993 with a degree in mechanical engineering. As is still often the case today, I was one of many engineers who get lured into the world of management consulting and banking. It paid a little bit more than a graduate engineering role, plus it was a bit more glitzy. I worked in institutional banking for just under 2 years, and while I learnt a lot and don't regret the decision, it wasn't for me, and I looked for an engineering role. I was very fortunate to come across a role as a systems design engineer for British Aerospace in their Melbourne office, working on a supersonic ship self-defense missile known as the Evolved Sea Sparrow missile. It's a system that's installed on 10 Navy's ships. If there's an offensive or threat missile inbound to your ship, you'd do a few things such as launch a decoy. And if all those failed, you'd launch this as a last-ditch attempt to save your ship. It launches vertically mostly, performs a pitch over maneuver, and then uses guidance control algorithms to intercept the inbound missile. I had also been offered a job designing car gearboxes in Western Sydney and had to choose between the two roles. I knew which one sounded more exciting for me, and despite knowing no one in Melbourne, I moved away from friends and family, taking a big leap into the unknown. As it turned out, it was the best decision I think I've ever made. It was an exciting project to work on. I got to travel the world because Australia was a guest nation for this NATO project, and there were 10 nations involved, all designing different parts of the system. Australia designed the dorsal control fins, the aerodynamic control fins, the guidance control algorithms, and the thrust vector controller. We pushed technology to new limits. We designed a system that could protect a ship like it hadn't been able to be protected before. Over the course of that 8 years or so, I was provided with so many opportunities to learn how to be a great engineer. I went to the US and Norway as lead test engineer. In both cases, I was so terrified. And in the case of the US, I didn't sleep for 3 nights before we departed. But I was able also to go out into the desert in Humvees with US Navy personnel at White Sands Missile Range to find our jettison thrust vector controller. I was asked to lead various work components, including the 6th degree of freedom performance modelling work and the thermal design work. I worked hard, I learnt a lot, and in return, I was provided more opportunities that provided me with more experience and more opportunities to learn. Of course, it wasn't quite as explicitly arranged like that, but that's pretty much how it all happened. I then went on to work on various other defence projects for 6 or so years. 15 years since moving to Melbourne, I emerged with an engineering mindset and skill set that I've drawn on every day since. I had the courage of my conviction, which meant I was confident to talk in rooms where I was the only female and 20 years younger than anyone else in the room. but only ever when I felt confident in subject matter. And that is still the case today as it was then. My confidence level depends on my familiarity with the subject. All good things come to an end, and drawing on my master's in international relations, which I'd undertaken in my spare time, one of my informal mentors brought to my attention some roles being advertised within the Department of the Prime Minister and Cabinet. I was 8.5 months pregnant when I went for my 2.5-hour interview. I had other things on my mind and quite a sore back at the time. So I was fairly relaxed about the outcome of the interview and was pleasantly surprised when I was offered a role as a senior policy advisor within the Strategic Policy Unit. Another big leap into the unknown. I thought that my master's in international relations was the reason I'd been successful, so it was much to my surprise that I found out it was because of my engineering qualification and engineering mindset and skill set that I was offered the role. They liked the structured way of thinking I used in my presentation and the problem-solving approach I'd used. It's hard to summarize what I learned over those 6 years, but let me say it was a steep learning curve about how government works and how policy is developed. But around the 2-year mark, it became more of a give and take relationship because I had a growing sense of frustration that we weren't going about grappling with complex policy issues the best way we could. I was in my early 30s by then, and it was then for the first time I really began to appreciate my engineering background. Until then, for the last 14 years or so, I'd been surrounded by engineers and I thought everyone thought like an engineer did. So it was a bit of a surprise to find all of a sudden that not everyone had the problem-solving mindset and skill set that engineers do. So I started to teach generalized engineering design and systems principles and methods to policy people within the department who are from all sorts of different professional backgrounds. These ideas caught on, and in 2014, I made another big leap into the unknown and started my own business structured around an approach to complex problem solving that I developed called Navigate Complexity, and which I ended up teaching into all faculties at university and which was available to all Commonwealth government departments. Another steep learning curve on how to run all aspects of a business. I had wanted to maintain my ties with my engineering background, and I had started several volunteer positions with Engineers Australia, including on the accreditation board. And it was during one of those meetings that I met the CEO. We got chatting, I found out that the chief engineer role was open, and 3 weeks later, again, very much to my surprise, I found myself to be the person in that role. I'm still pinching myself. Another leap into the unknown, another steep learning curve, more incredible learning experiences, and that brings us to today. Over the last 28 years, I've grown from a pretty naive, young, not very confident graduate engineer to someone who relishes solving complex problems for which there's no clear answer, fixing broken things, and making the world a better place. I'm someone who doesn't mind speaking up in any forum, as long as I'm confident in the subject matter. My career has never been planned. Each major turning point was completely unforeseen. I've made 5 big leaps into the unknown. Most of these I've initiated myself, but none would have been possible without the opportunities and support from my managers and mentors at the time, all of which have provided the fertile ground from which to learn and accumulate valuable experience while in each role. I have absolutely no idea what will be next. The only thing I'm reasonably sure of is that it will probably require a big leap into the unknown again, and that I'll need to draw on everything I've learned in the last 28 years to do a good job at it. And that brings me to my point, that each new adventure or career chapter has built on the earlier ones. To grow as a leader, I think, requires a person to have deep and/or broad experiences and actively and purposefully learn as much as possible. If you do that, over time you accumulate insights and observations which you can use later in different contexts. I think it's a reciprocal relationship between manager or mentor and the individual. A person's manager and mentors need to provide new experiences and opportunities, which occasionally stretch the person to work outside of their comfort zone, but which draws on their competencies and capabilities. And they need to ensure there's a supportive team environment. And the individual needs to reciprocate. They need to seek and embrace the new experiences and opportunities, and very importantly, observe and learn as many things as they can along the way. It's reciprocal and it's a long-term game. But it's amazing how quickly 1 year, 3 years, 28 years go by, and how many insights and observations you can accumulate along the way. The observing and learning along the way is a point I want to emphasize. If you read the literature on creative thinking and innovation, many people believe that the ability to think creatively and solve problems that haven't been solved before boils down to the ability to join the dots. That means that people combine ideas that they've come across before elsewhere into new combinations to solve a problem. So something they did 10 years ago, combined with an idea they read about last week, combined with an insight they gained from a conversation with someone about 5 years ago, combined with something they did 3 years ago, all combine into a new solution for today's problem. The observations or ideas you gather along the way are the dots. But the point is, you need to be observant throughout your whole career so that over time you accumulate lots of ideas or dots, so you have a bigger pool of insights to choose from and recombine for new challenges in the present. The more someone accumulates observations and learns, the more they can contribute useful insight and judgment, and in turn their confidence to do so grows. And I think while anyone can do what I've outlined, engineers have another few things going for them in the leadership stakes, and I'll come to those in a minute. First, let me address what I think engineering is. I'm often asked what engineers do, and it's a difficult question to ask because the profession is so broad, covering civil, mechanical, chemical, biomedical, electrical, all sorts of disciplines, and a whole host of emerging areas such as renewable energy, health, humanitarian engineering. The list is almost endless. And the different role types within each are also so varied. But if I had to distill what unites us all across all those disciplines, it would be this: engineers produce technology. Where produce is a catch-all for design, plan, build, prototype, test, commission, operate, maintain. There are many types of jobs an engineer can do. And where technology means any practical application of scientific principles and knowledge to do something. When you are trained as an engineer, you end up with several useful capabilities that are also valued in leadership. 1, engineers are pragmatic. We deal in the realm of the practical and we design and make stuff that works. 2, engineers think in terms of first principles. We have to. We design, build, operate technology, and you need to understand things deeply to ensure that the technology that you're designing works. Technology doesn't lie. It either works or it doesn't. So you can't really cheat. Engineers are taught how to design, test, refine their ideas iteratively so that they end up working. 3, engineers work iteratively and adaptively. It's a complex world. You won't get it right first time. That's why we prototype, test, learn, refine, and repeat until our solution works. In reality, we have to do that for most things that aren't simple, and it's quite second nature to engineers. 4, we are good problem solvers. Again, we need to be. Our job is to concoct a solution to a challenge within constraints and making trade-offs. That's a pretty handy skill to have as a decision maker in any context. 5, engineers are detailed thinkers, but they're also systems thinkers. We have to understand how all the parts work together to produce an overall outcome. This is the most important skill you can have in just about any occupation, I think, these days. And 6, in terms of mindset, we are typically curious people who like to learn new things, to understand how the world works, and to bring about better outcomes. All these traits and capabilities are important for engineering and leadership, so that's why many CEOs are trained engineers. It's also why, as an engineer, you can get a job in almost any sector. Our skill set and mindset is very valuable. 40% of trained engineers do not work as engineers, and that's unfortunate because we have a significant shortage of engineers at the moment. And it's why engineering graduates have topped the list of employer outcomes for the last 2 years. In other words, employers of graduates from all disciplines were interviewed by the government, and the graduates who are the most impressive to their employers, engineers. I bring what I've learned over the last 28 or 49 years really to my current role at EA every day. We have a raft of projects underway, but they're all geared around achieving 2 main things. The first is to strengthen professional standards of engineering in Australia. The engineering profession already enjoys a high level of trust from the community, but we want to strengthen that and position our profession well for the future. The second objective is really all about strengthening the identity of our profession in broader society. There's rarely a minute in all our days where we don't interact with the work of an engineer, but engineers typically work behind the scenes. The engineering profession needs more influence and broader conversations, not only because technology is just about everywhere these days, but also because engineers are good at determining how to bring outcomes about and thinking in terms of systems, which makes our contribution to most topics very valuable. My final point for you to consider as you start to think about what you might study next is really, don't stress if you're stressed about this decision. There are so many options and pathways these days. A decision this year or next year doesn't seal your fate. Your biggest challenge and highest priority, I think, should be to try and find out what types of things you like doing, what interests you most, and to determine what is the difference you want to make to the world. If you think in these terms, you'll start to head in a direction in which you can thrive. Thank you.
Jane, that was fascinating. Thank you so much for sharing your insights. I wonder if we can start with the first question, which is, in your opinion, is STEM a good path for future leadership? And if so, how?
Oh, Nick, look, undoubtedly, I think it is. STEM provides a rich range of transferable skills which you can apply in such a wide range of roles. If you study a STEM course, you'll learn many of these. And then if you use these skills working in a STEM career, you'll consolidate them and learn many more. I spoke earlier of the ways the engineering skill set and mindset is so valuable and transferable, and the same goes for science and maths too. Science and the scientific method teaches critical thinking, analytical skills, first principle thinking, and valid approaches for validating knowledge, which are also important for problem solving. Study in maths teaches you logic and how to approach problems. And at the end of the day, no matter what career you end up in, we're all problem solving. So a background in STEM sets you up really well for that.
So Engineering Australia has a wide range of programs focused on inclusiveness in industry and encouraging diversity. What do you see as the role that leaders need to play in driving the progress and closing the gap that our profession has?
I think there are some things that can be done in the short term and medium term to address the gap, both gender diversity, Indigenous as well, and numerous other dimensions. I think some short term, there are various mechanisms and policy settings such as quotas, targets, mentoring, leadership programs, zero tolerance for non-inclusive and disrespectful behaviour, and addressing structural barriers like access to childcare for gender diversity. But there's also some longer term things that we can look at, nurturing leadership, as I outlined in my talk. Those ideas apply equally to women and men in both the capacity as manager and individual. I don't think leadership is inherently different based on gender. What I would say, though, is that there are some structural conditions which have made these opportunities less available to women in the past, and which can also lead to lower levels of confidence at the risk of generalising. And that's something that we need to be very mindful of. We have a long way to go. Only 13% of the engineering workforce is female, and only 0.8% are Indigenous Australians.
The engineering profession is in an interesting position. We live in the age of automation when technology is perhaps changing our lives more quickly than they have ever before. And so while there are professional skills that machines can't master, and perhaps they're more important than they've ever been, how can students prepare themselves for people management?
I would characterise the highest priority skill this century as being able to work collaboratively with people in transdisciplinary teams, more so than people management per se. And I think there are two extremely important skills that everyone needs in this area. The first is the ability to properly listen to others. There's a wonderful and quite funny TED talk by Celeste Headley called 10 Ways to Have a Better Conversation. I highly recommend it. She talks about what it means to properly listen to others. The second is the realization that people can have diametrically opposed views and still both be right. I used to teach this principle, and the simple example that I often spoke about is imagining a number 9 written on a piece of paper, and to someone on one side of a table, it looks like a 9, but to someone on the other side of the table, it's a 6. There are two answers to the question, what number is on the piece of paper? And both answers are 100% right, but they're different answers. That's a simple example. So imagine for more complex issues how many right perspectives there are, but which are seemingly at odds. Many perspectives can all have some truth in them, even if they're polarized opposites. So I think this boils down to having an open mind. Listen to all views, all professions, all disciplines. Most people have something useful to contribute, and in this complex world, no single person can solve these problems. So we have to be able to work together and listen to each other.
So thank you, Jane. Thank you for your time today. Thank you for your insights, both in your address and what were really fascinating answers to the questions. I'm going to go and look up that TED Talk now. Again, I appreciate your time. I appreciate everybody's time for logging in and joining the conversation today. And again, I'd encourage everybody to think about STEM, think about the opportunities in front of them, and think about that as a future career.